Okay, let's get started. Okay, so today it's programming 4, right? Yeah. So this one is the programming 4, not programming 3. Right. Today we are going to spend a bit more time on the programming, right? Because I feel it's more important, right? So you need to have some full understanding on the programming part. So today we are going to discuss the functions, and also we are going to discuss for loops, right? And some other things, right? Okay, so what is function, right? So what is function? Function actually you see before, right? Last time in our Arduino IDE, right? For example here, right? We say we have this setup, right? Setup function. The other one is actually called loop function, right? Yeah, these are functions actually. Right? And also you have seen, for example, like pivot, right? Pivot, we define something, right? Or this digital write, right? We define something, right? That's all functions. Okay. So why do we need functions? So basically, you don't need to use functions. You can put all your codes right inside the main functions, right? But if your program is complicated, right? Actually, you will read your program is very difficult to read. Okay, so the function basically break your task right into a small parts, right? Then, for example, inside the loop, right, you can just put this way, right? For example, like inside the loop function, like you say, if industrial as a function, right? So whatever you want to perform, right, inside this function, you will put it in the other one, right? Okay. So if you read your loop function here, actually it's very clear. Okay, it's very clear. So whatever the detailed task, right, you can put it in the sub functions. Okay. So how to define a function? Right? So for any functions, right, the basic things is the input. What are the input? Arguments, right? You want to pass it to the function, and the other one is the output, right? What kind of values you want this function to return, right? These are two things which is very important. Okay. So to start, right? So you need a function name, right? So again, you need to give a meaningful function name. You can use actually you can use anything as a function name. For this case, you can use my function. Okay. So, okay, the first one, this one we put int, right? So this actually is the value we want this function to return. Okay. So if you want to return an integer function, you define as an int. If you want it to return a float number, right, then you need to put a float here, right? So it all depends on what kind of value you want to return, right? So if it's a double, right, then you change a different type, okay? Okay, so you have the bracket here, right? So here basically are the two input variables you want to have, right? So the first one basically is again a one integer value, right? The second one is a float number, right? So these are the two values you want to pass it into the function. So you want this function to use it for calculation, whatever, right? So anything you will put inside here. So this belongs to this function, right? So the last line will be the return, right? So return something, right? Return something. So this one basically is the value, right? You want this function to produce, right? These are the input, these are the output, right? Later I will give you one example, it will be quite clear, right? Okay, this is your input, this is the output, right? Okay, let's see one simple example, right? For example, is addition, right? So you just add two numbers. Okay, so if you want to add two numbers, right? The inputs basically you're taking two numbers, right? Then the value you want to return basically is the sum, right? Okay. So for this function, okay, your function name is add, right? ADD, add. So the value you want to return is integer number, right? So you define your function as int. Okay. So for this function, you want to take in two integer numbers, right? So int number 1, int number 2, right? These are two inputs. Okay. So inside this function, again, you have a new variable. Right? This one you can define that. Okay. So this variable basically belongs to this function, right? Which is called int answer. Right? So this is a new variable. Okay. So this answer equals number 1 plus number 2. Okay. This is addition, right? Then you're done, right? The addition is done, right? So you want to return this answer. You want to return this answer back to your main function. Okay, so how do you use this function? So again, if inside your loop function, right, you define a new variable called sum, right? So you use this function called sum equals add 4, 7. So what does it mean? So this one actually you are calling the function, right? Because the function is called add, right? Add. So for this function, you pass two numbers, 4 and 7, into this function. Okay. So basically, what you do is you pass 4 into number 1, right? And 7 to number 2, right? So basically, inside this function, right? Number 1 is 4, right? Number 2 is 7. Okay. So once you call this function, it will run whatever inside this function, right? So it will calculate answer equals 4 plus 7, right? So the answer basically is 11, right? Then this function will return.
No, I'm not. Because my holiday is 3 weeks.
Will return the result of 11, right? So this 11 will pass it to sum. Okay. Then basically the value of sum now becomes 11. Okay, so it's clear so far. Okay, so once you call this function, right? Okay, once you call this function, basically you pass these two numbers into this function, right? Then you need to execute whatever inside this function. Then the value will return back.
In the batch of the ones also studying.
Okay, then how about this example? Right? So if you call this function again, right? Now you pass three numbers, 5, 6, 7. So it will give you an error, right? Because for this function, right, you have defined, you can only take in two numbers, right? So if you pass 3 numbers, you will have an error because basically it's not right. Okay, you have to use the function according to what you have defined, right? Okay, so I will show you the example. Let me open a new file. Okay, today I want to show you a few things, right? So, last time we have discussed, right? Whatever inside this setup, right? We only run once, right? Whatever inside the loop, right? This thing will run continuously, right? Okay. So, I want to show you what is the meaning of it, right? So, we have used a serial, right? dot begin, right? Basically, this is the serial monitor, right? So we say we need to define the number of bits per second. Okay, this is standard, right? So, and we have used a serial dot printing line, right? Okay, we say hello, right? Okay. Let's say hello SID, right? Okay, so now if I upload my program right, to Arduino, right? So this one is so now it's uploading, right? Okay, no errors, right? Now you want to open the serial monitor, right? Okay, so you see, hello SID, right? Only print once, right? Yeah. Okay. So what happens if I release a print line, right? In here. So basically, this one will continuous printing, right? Because now it's inside the loop, right? So we say whatever inside the loop, right, it will be executed continuously, repeatedly, right? So you see what happens is, let's say I upload this program again. Okay, now I open the serial monitor. You see, now it's non-stop, right? Continuously printing, right? So you see the difference, right? Okay. Okay, next one, let me ask you. You see, the function I use, right, which is print LM, right? So basically, this one print line, right? So when you print, right, basically you see hello SID one line, hello SID second line, right? So what happens? Let's say I use the print. Print again is a function. It's a valid function. So if I use print, that means actually it's not printing one line by one line, right? You see, you will see the difference. Let's say I upload this again. Okay, so I open the serial monitor again. It's not a new line. It's just append to the previous hello SID. Okay, that's the difference. Okay, now I want to show you the function we discussed, right? Let's say we want to write a new function, right? Which is called add, right? Okay, so we write a new function, right? So again, for any functions, right, we need to define a type, right? Okay, this one int, right? Add. Okay, so the input is two numbers, right? So we can use any name actually, but you need to be consistent. Okay, let's say I use S1, I don't use number one. Okay. X2, right?
Cannot see, huh?
Okay, so this is inside my function, right? So inside my function, I want to define again, I use the sum right here. Okay, sum.
Tell me to zoom
So
in.
sum equals x1 plus x2. Okay, so here is what I mean is you need to be consistent.
Just
You
kidding.
define your input as x1. So here you need to use x1, right? If here you define as just now like in your notes, right? You use the number one, right? So here you need to use the correct variable name number one, right? Okay.
Sir, cannot see.
Can zoom in?
Sorry. Okay. Cannot see. This last time we use magnifier is not so easy. Huh? Okay. Okay. So now, we use x1, right? So then you need to return, right? Return sum. Okay. So this is my function, right? For adding two numbers. Okay, so far. Okay. Now. So again, I want to use this function in the setup. I only want to run once. I don't want to run So I put my code under the setup. I use green line. Okay. So for the green line, let's say the first time I want to do a summation, let's say 3 plus 6, right? Equals. Okay, inside my green line, I call this function f 3, 6, right? Okay. Okay, so I use this function, my add function. Okay. So if you after you call this function, it will produce the result for you, then it will bring out. Okay. Okay. Let's say I want to call this function again, right? I use green line. Let's say this time I use 30 plus 60. Okay. So I need to call this function again, right? So I pass these two numbers, 30 and 60. Okay, so basically this is the program. So what kind of output you are expecting? Huh? So the output, if I run this program, the output I should get is the first one is 3 plus 6, right? It equals 9, right? Then the next line will be 30 plus 60 equals 90, right? So these are the outputs we are expecting, right? Because we call this function 2 times. We call this add function 2 times. The first one, we pass 3 and 6 into the function. Right? The second one, we pass 30 and 60 into the function. So we call 2 times. So it should produce 2 outputs for us, right? Yeah. So, okay, let me upload the program. Sorry? Do you see any error? Sorry? Okay, so this is good one, right? So whenever you write a program, right, it's very common you will see some error.
Integer add there.
So anyone see any
Integer x2.
integer x2?
The bracket wrong.
Wrong bracket.
The bracket wrong.
Where? Sorry, where is it?
Integer x2.
Integer, this one is it?
Yeah, the bracket behind.
This bracket is for the bottom one.
Oh. This is correct.
Let me see, because my monitor here is not working. Sorry? And then you don't see any error. I know. You know, I cannot use this one, right? I need to use serial, sorry. This is a Okay.
You copy? Later I show you.
Okay. So the result is what you expect, right?
Use calculator better.
Okay.
I'm not saying.
So basically, you see, once you write the function, right, you can use it as many times as you like, as long as you pass the correct inputs into it.
You need to share the data from the
Right?
data from.
Okay. So is it okay so far? Okay. Well, it's good. At least you see some. When you write your program, actually it's very common, right? You see things like that, errors. So you need to start debugging. Okay. So very common mistake is those things I mentioned to you, right? For example, like the case, right? The case sensitive, right? And the other one is the very common mistake is you forgot the semicolon. Because for C programming, right, semicolon is a must. You have to end the line, right, with a semicolon. Right? And other things you mentioned, for example, like subtracted thing. Yeah, that's not remind me. That's also very common mistake. Right? And also just now this one, yeah, the function name. Okay. Okay, so this one we have already practiced. Right? Okay, next one. Okay, let's say we want to flash an LED, right? And the last time when we do the flashing, right, we actually will just put a number here, right? We just put a delay, right? Delay how much, right? 1,000. A fixed number to it, right? But actually you can write a function, right? With the input as a delay, as an interval you want to control. Okay? So basically you can write a function, let's say you call it as a flash. Okay? So the input basically is the interval, the amount of time you want to control. This is your input. Okay. Do you notice here I use void? What does the void mean? So void basically tells you this function I don't need to return anything. So I don't need to return anything. It's called void. So what it means is this function, right? Basically inside this function I will turn on the LED, turn off the LED, right? Yeah. So after I done this, I don't need to return any value. Okay, so this is what you can use void to define your function. Right? No value is returned. Okay. So when you use this function, basically you just call this function as a flash. You pass 1000, right? So what it means is, let's say you pass 1000 into this function, right? So this value basically will be appear here, right? Delay. So this interval now become 1000, right? And this delay also become 1000. So basically, you want this you want to flash your LED, right? At an interval of 1 second. Okay. So the next time, let's say you pass a flash 100 into this function. So now, basically, your interval, right, becomes 100 milliseconds. So, which is 0.1 second, right? So you pass 100 into the interval, right? This value. So now your delay becomes delay 100 and delay 100. Right? So basically, you are flashing your LED at 100 milliseconds, right? So you get it, right? So basically, you see now. You see the usefulness of this function, right? Yeah. So whatever here are the standard steps, right? What you want to control is the interval, right? So you just write a function and you just pass the value into it, right? And actually control your interval. Okay? And can you do it this way? A flash, you don't pass anything, right? It's not allowed because for this function, I need one and only one input. Okay? So you cannot pass nothing. If you pass nothing, you will have error. Or you cannot pass two numbers. If you pass two numbers, also you will get error. You can only pass one number because that's the definition of your function. Okay? Okay, next one. Let's say you want to flash an LED up to 2 times. Okay. 2 times. So if you look at this program, right? I think you will understand what's going on. Okay, you look at this function is void, right? So this function does not return anything, right? So the function name is called flash2, right? So the input variable is you use the name is how many times. Okay, so again, this variable is meaningful, right? So if you look at this variable name, you know what is the meaning of this input, right? So this variable name called how many times. Okay. So if how many times equals 1, right? So that means if you pass 0, equals 0. So if you pass 0 into here, so if you pass 0, you will go into this if, right? If loop, right? So inside if loop here, nothing is it's empty here basically. Yeah? So if you go into here, you just return, right? So okay, one thing I want to mention to you is there is a semicolon. It's missing here. Yeah, there is a semicolon. This one is wrong here. The original notes. Okay, so if your how many times is 0, right? So it will return. So it will exceed this function. Okay, now let me ask you, if my input here is 1, so what happened? So if it's 1, right? So again, you go into this function, right? You will check this one again, right? So this one is not true, right? So this is not true, right? You go to next. So you flash 300 milliseconds, right? Okay. Then you go into here because now it's 1, right? If it's 1, this is true, right? You go into this if loop, right? So you will return, right? So that means if how many times is 1, so this program actually flash LED 1 time, right? Which is correct, right? Okay, this is right. Okay, so if it's 0, it doesn't flash, it will return, right? Which is also correct. Okay, now let's check. If how many times is 2, what happens? So if it's 2, right? So you come to here, it's not true, right? So you flash 1 time, right? You come here, again it's not true, right? Because it's 2, right? So again you flash 1 time, right? 2 times. Okay, so again, this function looks alright, right? Okay, let's say now, if how many times is 3, right, what happened? So if it's 3, you come to here, it's not true, right? Right? So it basically this one, you will be skip, right? Because it's not true. So you flash one time, right? So because now how many times is 3, this one also not true, right? It will be skip, right? So you flash one time, right? So that means if how many times is 3, it only flash 2 times. Okay? So this is what happened, right? Okay, now let me ask you, if my how many times is -1, what happened? So if it's -1 here, not true, right? So flash 1 time. Not true, right? Flash 2 times. So if how many times is -1, again this function flash 2 times. Right? Okay, so you see this function, right? This function actually is not well written. It seems alright for some values, but actually it's not well written. You see. So you see, if how many times is a negative number, any negative number, right? -2, -3, -4, right? The LED actually flashes 2 times, right? Right? Yeah. So this is the program. Yeah. Sometimes you see when you check for certain conditions, it seems to work, right? It seems working, right? But actually, it's not a program. Good program. Right? Okay. Okay, so for the setup function and loop function, actually we have discussed. So basically, these are all functions, right? And whatever inside your setup, right? Basically, you only run once, right? Whatever you put inside the loop, right? You will run continuously. Okay. Next one, I want to discuss the for loop, right? For loop, again, is a very important loop you should know, right? So for any programming, actually, for any programming, not only for C, you have the first one is the if-else loop, right? We have discussed last week, right? This is very important. Second one is the for loop. The third one is the while loop. Basically, you only have these 3 basic loops for any programming language, which you should be able to use it correctly. Okay. So what is the for loop here? So for loop basically for any for loop, like you need 3 parts basically. You can say you can A, B, and C. What is A? A basically is the initialization, right? B is the condition, right? Whether you can continue or not. C is the variable update. So what does it mean? Let's say we check one example. Okay, so if you look at this for loop, right? So we say the first condition is the initialization, right? So you initialize your I into a value of 0. Right? Okay, so that's the starting, right? So this is the condition you want to check whether you want to continue the loop, right? So which is I smaller than 5. So this means if I is less than 5, you will stay in this loop. If I is bigger or equals than 5, you will exit. So this is the condition for the for loop, right? So this is the variable update. What does it mean? Basically, it means every time you execute this loop, right, you update the I by 1. You increment this I by 1. Okay, let me go through step by step because this is important. Yeah? Okay, let me change to. Okay, we have this program, right? Integer x equals 0, yes? So you have a for loop, right? Which is I equals 0, right? I less than 5. I equals I plus 1. Right? Okay, so inside your for loop, basically you have x equals x plus I, right? Okay, this is your for loop. Okay. So what is this program, right? So the first step, okay, so you look at your for loop, right? This is your initialization, right? So at the beginning, I equals 0, right? So I equals 0, you check if I is less than 5. So 0 is still less than 5, right? So, okay, so you go into this loop, right? So you execute this one, right? Right? So in the first step, basically, is x equals 0 plus 0, right? Because now x is still 0, right? Right? I is also 0, right? So this one, x equals 0. Okay? So this one is done, right? You go back to the loop again, right? So because this is your update condition, right? So now that means your I becomes 1, right? Right? Because this is your variable update, right? Okay. So I equals 1, you check if I is still less than 5. Still true, right? Still true, you go into this loop, right? So now you need to check x. You need to update your x, right? So now it's 0 plus 1, right? Because now your I is 1, right? So your x now becomes 1. Okay. So after you finish 1, you need to update I increment I by 1, right? So now I become 2, right? Then you check again. If I still less than 5, true, right? So you go into this loop, right? So now x here is 1, right? I is 2, right? So now the new value for x is 3. Agree? Okay. So after this one, you increment your I by 1, right? I equals 3. So you check I, is it still less than 5? True, right? Okay. So now you do this again, right? 3 plus what? 3, right? 6. Okay. So again you update your I by 1, right? 4. I equals 4. So you check again. Is it I still less than 5? Yes, right? So you do again, right? This is what? 6 plus 4, right? 6 is this one, right? This value of x. 4 is I, right? So this one equals 10, right? Okay, then you update your I again, right? So I equals 5, right? Okay. So now you need to check the condition. So is I still less than 5? No, right? So exceed 4. Okay. So this is what happened for the for loop, right? Is it clear? Clear, right? Yeah. So you see what this for loop do basically is do a summation, right? 1 plus 2 plus 3 plus 4 up to 4. 1 plus 2 plus 3 plus 4, right? Equals 10. Right. Okay, let me show this program. Okay, so start with the serial output, right? Okay, so now we want to have a integer sum, right? Equals 0. So we want to have a for loop, right? Okay. So we put for. Let's see this one. Huh? Integer I equals 0, right? So this is my initialization, right? Less than 5. I equals I plus 1. This is my update, right? Okay, so what I want to do is I do a sum, right? Equals sum plus I. Okay, so this is what we have discussed just now, right? Right. So for this for loop, basically we sum 0, 1, 2, 3, 4, up to 4, right? Because your condition is less than 5. Right? So you will sum 0, 1, 2, 3, 4. The result will give you 10, right? So you want to print out the result to see, right? Okay, it's a serial string line, right? So you say the total sum is, right? Okay, then serial right? You want to print this sum, right? Okay, so is it okay so far? Okay, so now we can upload the program. Okay, so you open a serial monitor. Yeah. So the total size is 10, right? Okay. So you want to try the other one? Anyone still remember? Let's say if I want to do a summation up to 100, I waste the value. Anyone still remember? 100, right? 101. Anyone have a guess? What is the value? If you do a summation from 1 to 100. No? 5050, right? Okay, let's see. Okay, so basically that gives you the idea, right? For loop, right? So basically for loop, right, you can control how many times you want to run, right? By setting up the correct conditions, etc. Okay? So for loop, basically you see why it's useful to have a for loop, for example. So let's say you want to write something 100 times, right? For example, this case, right? If you don't have a for loop, basically you need to write the code 100 times. Right? But once you have this for loop, right, basically you can make your program run a lot efficient, right? I mean, your code looks a lot more efficient. You know, for the beginner programmers, right? Actually, it's a common mistake is sometimes like if you want to ask him to repeat something for 10 times, right? The programmer tends to repeat the code 10 times. It's alright, I mean, you can produce a result, but your basically it makes your program looks very, how I say, unprofessional. Okay, so you should use this kind of for loops, right, and to make your program easy to read and also more efficient. So this is one of the very important rules, right? Okay. So actually, I would say, you see, last year I told you, last year in the exam paper, the lecturer asked you what is the if else, right? So this year I'm not sure whether it's this one. Okay, it's just my prediction. Okay, yeah, be careful. Follow, right? Okay, because I did not send the paper, but this is just my some guess. Sorry? Alright, so let's come back to here. So we have the for loop, right? Okay. Okay, let's see the other one. Okay, so let's say now you have the x value equals 1, right? So you have the for loop. The initial value is 1. I is less or equal than 5. So the update basically you need to increment your I by 1. And x equals x times I. So what it means is in the first step, right? In the first step, your I equals 1, x equals 1, right? So 1 times 1 is 1, right? So then your I change to 2, right? Then you do I times 2, 1 times 2, right? So now your x is equals 2, right? Right. The next step, I becomes 3, right? It's 2 times 3, right? So what is the result of this one? What is the result of this one? Basically, it's a factorial of 5. The 1 times 2 times 3 times 4 times 5. Think about it. So this is actually is a factorial of 5. Okay. Next one. So yeah, so this one, so if you want to rewrite the program we discussed earlier, right, to refresh the LED, right, depends on how many times the variable, how many times, right? So what you can do is you write a function fresh n, right? So this is your input, right? How many times, right? And this is your interval. So you see this function, right? You have 2 inputs, right? The first one is tells the program like how many times I want to run. Right? The second input basically is tells when you flash the LED, right? What is the interval, right? So these are the 2 inputs. Okay, so inside here you use a for loop, right? So the initialization is I equals 0, right? I less than how many times, right? So you see, if you have a program like this one, right? So the problem we have discussed earlier, it won't happen. Just now the issue we have for the program basically is if you how many times is a minus is a negative number, your program still flash 2 times, right? That's the problem just now we have, right? Then if you look at the function here, if your how many times is minus, so does this LED also flash? So if your how many times is minus, right? So let's say it's minus 1, okay? So you go into this function, you go into this for loop, right? So initialization is I equals 0, but then you check, is I less than minus 1? No, right? So that means if your how many times is minus 1, this one never be executed, right? So it actually solved the problem we have just now, right? and the program looks much much shorter, much neater, right? Agree? Agree? But there is one issue now, which is what? This one, if your holding time is, let's say, 3, so you go into here, so actually this for loop, right, it will be executed 3 times, right? It will be executed 3 times, right? Right? So this function basically is not like you want to, the LED to refresh maximum up to 2 times. Yeah, this is different. Okay. Anyway, that's the idea, right? Okay. And of course, for the for loop, right, you can write it in a different way. Right? You can write. So for this one, we say we increase your I, right? Every time by 1, right? Plus 1, right? But you can write the other way. You can go downwards. Yeah. So you initialize as I equals how many times, right? Okay. So then you check whether this I is still greater than 1, right? So you decrease your I by 1 every time by 1, right? So that's also okay. They are equivalent, it's the same. Okay? So it's the same thing. Right. So so this is the program we discussed last week, right? I think this one, yeah, you can go back to read through it. Yeah. So I think now you can understand the program we discussed last time. Okay. So here you use a for loop, right? So you just read through the program. Now make sure you understand this program basically performing the same thing we had discussed last week. Right? So I will leave it to you. Is it okay? Okay. Okay, so now if you have a for loop like this one, right? What's going on here? So we say for for loop, right, you need A, B, C, right? But now you don't have anything. Yeah? You don't key in anything here, but you just put a 2 semicolon here. So what does it mean? So what is this loop doing? So if you don't put any conditions or any initializations, right? This loop basically will run. It's an infinite loop basically. It's infinite loop, right? So it will run continuously, right? Infinite loop. Okay. So once you are inside this infinite loop, right? Basically you cannot get out. It's infinite. So what, if you have a program like this one, right? The program cannot stop. So you need to have some condition to break out of this loop, right? So you can use the break keyword, right? Break statement. So you need to set certain condition, right? Once this condition is met, right, you need to break out of this loop. Okay. You have an idea, right? If you use this kind of for loop in your program, right? Yeah, you need to have certain conditions, right, which you can get out. Otherwise, your program cannot stop. Right. So one way is you can use the break. Okay. And this is the exact example we are going to discuss further in the next lecture. But I encourage you to look at this example and come up with your own flowchart. And also you can write down your own program. So this example, right, actually is a similar level as the exam questions. Okay. So this is the typical. I mean, the kind of amount of the codes you need to write and the flow chart you need to come up, right? Yeah. this is the exam question level, right? So try it. Next week we are going to discuss it. Is it okay? Yeah, try this one. Okay. Okay. Next, I want to show you the flash. The flash LED example, right? We discussed just now. Okay, let me remove this part. Yeah, the flash LED. That's great. Yeah. Okay, let me let it go first. Okay, again, first we write the function, right? The flash function, right? So this is the same as what you have seen in the notes, right? So we pass the integer value, right, as the interval, right? Okay, and so inside here we just use the integral, right? So we want to control your LED. So delay, right? Then you use the digital light. Turn off, right? Okay, you delay something. Okay, so this is the function you have seen in your notes, right? Okay. So here again, last time when we want to use the LED pin, right, we need to define an integer by LED equals 10. Right? So we want to use pin 10 for the LEDs. Okay. So the first thing we want to use we need to define a P mode, right, for LED output. Next week, Thursday, right, we will have the first lab, right? Yeah, so I will send out the group name, right? Because you have two groups. So I will send out the student name and also the lab sheet. Okay, so for this one, okay. So the first one, what I want to do is I want to flash 200 milliseconds or in 2 seconds, right? Then I want to do a delay, right? Delay for 2 seconds. Then I want to flash again for 2 seconds, right? Okay. So you understand this program, right? So I have a function, right, which is called flash, right? So this flash basically taking the interval as my input, right? The interval basically controls the the duration, how long you want to flash. So inside the setup function, the first one I call this function, I flash 200, right? Basically I pass 200 into this function. Right? So basically the LED will flash by 2 seconds, on for 2 seconds and turn off. Then I want to introduce a delay, right? To make you will see clear. I mean, later you will see. So I want to introduce a delay 2 seconds. Then I want to flash again 2 seconds. And this is the program, right? So now I want where's my mouse? I want to upload my program. Okay, so no error. Okay, so let me check here. Okay, so this is my Arduino board, right? So now my program actually already inside, but I haven't connect my my LED yet. Yeah. So the program has already stored inside Arduino because just now I upload my. Okay. So next one I need to connect the wires, right? So still the red line I reserve for the 3.3 volt, right? Black wire I reserve for the ground. Right? Okay, so the next thing I need to do is for LED, right? I use pin 10, right? Just now. Okay, so I just need to connect my this wire to pin 10 is here. Okay, so now if I press okay, it doesn't work. Oh, sorry, pin 10 is here. Right, can you see the difference? You see, just now I say, right, the first one is a LED flash by 2 seconds, 2 milliseconds, right? Then it will delay 2 seconds, then it will flash 2 seconds, right? Okay, let's do it again, right? Okay, I press this reset button. Delay 2 seconds. 2 seconds. Okay, so it will happen. Right? Right. Okay. Next topic I want to discuss is the communication. Okay, so the communication. So why do we need communication? Because you see, we have already discussed, right? For any embedded system, the core is the microcontroller, right? It's the ARM core we discussed, right? The same 3X chip we have discussed, right? That's the core. But you need to use this microcontroller to control other things, right? You need to control your speaker, you need to control your motor, you need to control some other things. And also you need to transfer your data, right? Yeah, to other components. So for all these things, you need communication. Right? The microcontroller itself actually is like a brain. It's like a brain. But you need to pass the message to different things. Okay? So this is the communication comes into play. Alright? Okay, so for communications, right? For this machine communication actually is similar to our human communications. Right? We need to speak in the same language so that we can understand. Yeah. So that's why we have different protocols for communications. Right? One of the common one is the I2C actually. Yeah, this is for integrated circuit bus. Right? Because if you look at your computer motherboard, right? Have you seen your computer motherboard before? So inside your motherboard, right, you have one microprocessor, and you have a lot of chips in the motherboard, right? So to communicate between these different chips, you need to use I2C. Okay. And we have also the other communication protocol is the RS232, right? This one is the last time the serial protocol. So what is the most popular communication we have? Well, PC to this is the old one. What is the USB USB, yes. The USB has replaced most of these IS232, right? Okay. So why communications? Yeah. So this one we have. So this one we have discussed a little bit, right? Basically, for different parts, right, to communicate, right, you need to have the communication, right? So if you look at the washing machine again, right, so this one we have used many times. Okay, so for washing machines, last time we discussed what are the inputs for washing machine. So you have this user control panel, right? You have input from different sensors, right? Temperature sensor, water sensor, whatever, right? And you have what? You have some other inputs also. So what are the outputs from the washing machine? Right? The washing machine, the first thing you need to control a motor, right? So you need to have a I/O to control motor PWM, right? This one we discussed. And you need to have you need to control some speaker, right, to give out the indication, right? If the washing is done or what kind. So this is your speaker. And what kind of control? You need to display something, right? Okay, that's your output also. Right? So what are the outputs? Okay, you need to control the water valve, right? Turn on and turn off the water, right? Right? So these are the output from the washing machine, right? So all these you need communications, right? Because this one basically connects to a different components, right? So these are the some of the mechanical components, water valve, whatever, right? Right? And this is motor, right? Right. So how you want to run motor, reverse, clockwise, counterclockwise, how much speed, whatever. Right? Okay. And if you look at the data acquisition system, again, inside here you have a microcontroller. Right? So this microcontroller basically connect to a different. The data acquisition, basically
Actually now,
you have a lot of sensors, right? So microcontroller will connect to different sensors, and also it will connect to different equipment, right? So for many these measurement equipments, right? Actually we use the standard we call IEEE, PIB, whatever. Have you heard it before? Yeah. So for a lot of these measuring equipment, right? We use IEEE standard. That's actually is a different protocol. Sorry. Yeah. Okay. So this actually is the other family of the communication, right? Which is coming from the IEEE standard, right? For the especially for the measurement equipment. And this microcontroller also can connect externally, right? To, for example, like to LCD display, etc. And the most important part, right, for the data acquisition is actually the microcontroller need to connect to a PC, okay, to a PC to transfer data, whatever. Yeah? The PC also will give a command, right, to the microcontroller what you need to do, right? So this one, the last time we used the serial RS-232 standard combination. Okay, so that gives you an idea, right? Why we need communications. You see? So you see, in this picture itself, right? You have three protocols, right? One is the IS-232, right? One is the I2C, we discussed that, and the other one is the IEEE bus. Okay, so communication within a piece of equipment. Actually, you can use the I2C, and also you have some other communication, for example, like serial communication, etc. Okay, so this is what we have discussed. And okay, so besides the different protocol we have discussed, right? Actually, there are a lot more. So, for example, the cars, right? So these days, right, the car actually is become very complicated. Especially now, you have a lot of automatic driving and a lot of sensors, right, adding, right? And you need a lot of it's a precise control of engine movement and whatever, right? So now the car actually is far more complicated than 20, 30 years ago, right? So you need a lot of there are a lot of functions, right? You know, right? Yeah. For example, like the auto parking, right? And whatever, right? Even the auto driving, right? Last time it was manual, right? Now it's most of the cars are auto driving, right? So inside all these cars, you have the different standards. Yeah, they call it 10 plus, and also the link plus. So these are the protocol you use for cars. Right? This one basically just give you an idea. There are actually a lot of protocols in the market, right? And depends on the applications. And to communicate with the computer, right? So last time we had this serial, right? Serial communication. Okay, and sometimes you heard about it is a COM1. And for the type of communication, it can be serial or parallel. Okay, what does this serial and parallel means? Right? Okay, so the serial basically the data is sent bit by bit. Okay, so let's say we have 8-bit data, right? 8-bit data. So the data actually is sent bit by bit, 1 bit by 1 bit. What is the parallel means? Parallel means if it's 8-bit data, right? If you send it parallelly, right? So actually we can send out the 8-bit data in one shot because you have 8 buses, right? So each buses sends out 1 bit, right? So you can set up the 8 bits in one shot. So apparently, right, if you compare to serial and parallel, parallel is faster, right? Parallel will be faster, and serial will be slower because they only send out the bit one by one. Okay. And we have this we have this called full duplex and half duplex. So what is a full duplex mean? Full duplex basically means your transmission and receiving, right, can happen in the same time. Right? And half duplex basically means it's only one direction. Okay. Maybe let me show you one video. Right? It will be easier for you to understand. I think this video is explained well, but I'm not sure whether we can get the sound out of it. Let me try.
Okay, so I was like, wow, that's really cool. So yeah, now we just gotta redesign it a little bit and get it ready for production. Interfaces. What are interfaces? Well, interfaces are predefined ways to communicate between electronics. For instance, you might have a microcontroller here, and you want to talk to a temperature sensor. How do you do that? You do that with an interface. The temperature sensor will have an interface such as SPI, and you're like, oh, that is the way I have to communicate between my devices. So why do you need interfaces? Well, microcontrollers don't have that much I/O. Even a really large one, there's always a limit. So you're going to run out of I/O eventually if you hook up enough stuff. Interfaces gives you a way to use less I/O. And the more important reason why you need it is because most external devices require an interface. If you have an EEPROM, it's not going to hook up with a bunch of individual parallel wires. Well, it might have 20 years ago, but not anymore. It's going to say, hey, this is an I2C EEPROM. So they're like, oh, I need the I2C interface in order to even use this thing. So that's what it boils down to. You need interfaces because to hook up anything beyond like an LED or microcontroller, you're going to need an interface. Whether or not you realize it, you've seen us use interfaces before on the show. The robot luggage, for instance, used RS-232. The hand sanitizer used SPI to communicate with the SD card to write data. And the can cooler, for instance, used I2C to read the temperature of the can. What are these interfaces? We'll discuss that now. Here are the three very common interfaces we're going to go over in today's episode. I2C, which stands for Integrated Circuit. It has 2 wires, including clock and data. SPI, Serial Peripheral Interface, or sometimes interchange, that has 3 wires plus 1 chip select wire. And the third one, the oldie but goodie, RS-232, recommended standard 232, 1 or 2 wires with no clock. We'll start with an I2C example. I2C will have a master device that has serial clock and serial data lines on it. These lines will almost always have pull resistors on them. Sometimes it'll work without the pull resistors, but it's not a bad idea to put them in. Then in this example, we have 3 slave devices. We can have up to around 120, I want to say. Each one of these devices has a serial data and serial clock line of its own. So here's how it works. The master device sends out a device ID command on the bus, like wake up device 0. Device 0 is like, oh, that's me, and it acknowledges back. The other devices don't do anything. Once this is like, oh, I'm talking to device 0. Device 0, here's your command. Device 0 is like, okay. And then the master device will either do a read or write data or some sort of command to the device, and that's the slave ID. So it's all based off of the device ID, and it's always the first thing you send out on the bus. The advantage of that is you can have a ton of different devices on one 2-wire bus, which saves you I/O. However, it's slow, and oftentimes if you have different devices, the manufacturers just kind of pull numbers out of a hat what their ID is, so you might have conflicts. So, few pins, slow speed. Now it's like the I2C bus in action. We have a small IC2 device here. This is an IR proximity sensor. It sends out an IR infrared light.
Yeah, this is also Arduino.
Back into the sensor.
No.
And therefore it can detect how close something is. It's a very small sensor, but I was able to wire it up to this breadboard here. So. Off the sensor, we have the two I2C lines. I2C has serial data and serial line, which we call SDA and SCL. And you need pull-up lines on each of those. Pull-up lines where you have a 10K resistor, right? 10K resistor connected to positive power going into the line, so the default state is always high. So if you're having trouble with your I2C bus, make sure you have pull-up resistors on both lines. And those go into the Arduino here, and the Arduino is reading them and putting the data out on the screen. We already discussed how we have to ask for the data, so that's already programmed in. So if I move my finger here, it's actually a 16-bit value, but I'm just looking at the lower bits. See the number change, and then move my finger back and forth from the
So this is the distance sensor, right? I think the lab 2 you are going to use it.
two-wire bus, which is a great advantage. One disadvantage though is it's kind of slow. You've seen how many different calls you have to make just to read that off. But if you don't need a lot of speed, it can be a great solution, and it's a very common. Our next example is SPI, Serial Peripheral Interface. SPI has three basic connections: master out, slave in,
This
slave out.
You look at the video first. Next we are going to discuss again.
Unlike I2C, you can't just put all the devices on one bus and address them with that. You have to actually manually activate the devices with an enable line. So let's say you want to talk to this device, slave 1. And let's say slave 1 is active low. You set its chip select line to low, and this one will be high, which means you're talking to this guy, and this guy isn't going to be doing anything. So what you do, after you do the chip select, you send a command, so you would clock that out, master out, slave in, comes out of the master into the slave, master out, slave in. Slave will also send you back some bytes. They may be null data, but whenever you shift something out, something's always shifted back in. Interchange, that's where the interchange comes from. So if you send a command, let's say you're like read memory position 5, then you just clock a bunch of null zeros into slave 1, and it'll return you the data you want. So again, it's always an interchange. Once you've got the data out of slave 1, let's say you set it back to being high, you want to read this guy, and you set him to being active low, and then you're supposed to be talking to this guy, and this guy will be ignored. So yes, you're always putting bits in and getting them out in the same clock cycle, although you can ignore the bits you get in because of null data, basically. SPI is faster than I2C. It's also just as common. However, having to have a chip select line is kind of a disadvantage.
These donuts look fat. Chip, can you unsend an email? Who's the new girl? What's wrong with business casual? Is Carl joining the call? He keeps taking my sandwich. You think I do good stuff, man? You guys seen Carl this week? Did we get those bonuses yet? Will this software really work? How do you remove a virus?
Getting straight answers to all your questions at work.
Where is everyone?
Not as easy as it should be. Getting answers to product and technical questions from a team of engineering experts, definitely easier. Discover how we're listening to your feedback and building a better experience.
Oh, let's work here.
It's the commercial. I don't think right, yeah.
Particular temperatures.
I don't see this one.
You're trying to ship select everybody, you have to select the SPI about small. Here we have something weird. It's set data mode. It refers to the phase of the clock.
Yeah, okay, you see, Arduino, right?
0 through 3.
You can actually use the SPI.
It doesn't use the standard mode. So
SPI it has a library,
SPI.
SPI library. Yeah. So if you want to use, actually you can download the SPI
So if
library.
your device isn't working, try setting different data modes. I couldn't really find it in the data sheet either. I just had to basically try all three or all four of them. All right, so here's the main loop. When you want to talk to the SPI device, you pull your chip select line high or low. Your data sheet will tell you it's active high or active low. This one is active high, so that means we go from 0 to 1. And while chip select is 1, that's where we go our SPI business. In SPI, as we mentioned, everything is a transfer. So if I'm sending 8 bits, I'm getting back 8 bits. And I might not want these bits that I get back, but I need to send the command. It's an interchange. Sometimes people actually say serial peripheral interchange as well, instead of interface. So here we're sending a text A, which means, hey, we want to write the control register. And then we're sending all zeros. The default state of this temperature gauge is to not continuously take temperatures. So by setting all the bits of the control register to 0, we're telling it to continuously take temperatures. You just have to do that once, but we have to do it when it boots up. The default state is to not continuously give you a temperature. Then we just have a
So basically what it means is, for example, like let's say in your project, right, you buy a sensor, right? And if you look at the data sheet for the sensor, right, it tells you it uses SPI protocol, right? So that means if your Arduino, right, is communicating to the sensor, right, you need to use SPI
You can
protocol.
find out from the
Okay, that's what it means. Okay. So for Arduino to use the SPI, yeah, you need to have a SPI library.
Byte temp equals SPI.
Okay, so you see the code here, right? The first one is SPI dot begin, right? That actually is from the SPI library.
Then we turn off.
And then the other thing is, for example, SPI dot transfer, SPI transfer, right? Yeah.
So we'll flash this to the Arduino and then we'll show you an example. Here is the SPI temperature sensor, wonderfully hooked up to this Arduino. Again, it's a service-bound part, so I just soldered it the best I could.
Yeah, so this is a temperature sensor.
Which is actually the same thing you use to flash an AVR chip. So it's hooked up to the SPI bus here, and it's sending this data. So on the screen here, we can see the current temperature. It's saying 62 right now, so if I touch it with my fingers, it should warm up because
So 62 is actually Fahrenheit. It's not Celsius.
So what I learned with the SPI bus, at least with this chip, is you have to set the modes of time or doesn't work. Another great example of SPI bus is SD cards. They have 2 modes actually. The high-speed mode, which is what your digital camera may use. You need a license for that. But any sort of like microcontroller application, they almost always use SPI mode as well. The last interface we're going to look at today is RS-232, recommended standard 232. It's pretty simple to use. You have a master device, transmit and receive lines. Over here, receive and transmit lines. And notice how they are crisscrossed. So transmit here is receive here. Transmit here is receive here. It's pretty easy to use. There's other lines on the standard, but we don't need those anymore. Some disadvantages of it though, it's slower. Also, it has no clock, asynchronous connection, so it's prone to interference. But 9 times out of 10 it works just fine. For our RS-232 demonstration, we're going to use this FTDI chip. It's called the FTDI RS-232. It takes your USB signals, like from your computer, and turns it into old school serial logic. I should mention RS-232 actually uses positive and negative voltages, like the 12-volt range. That's old school serial over long distances. This is the same kind of format that uses 0 to 5 volt first levels instead. And for my demonstration, I've got hooked up to an EMIC 2 module. I got this from Parallax. And this is a speech synthesis module. So RS-232 is really simple. It just basically is it's the data packages where it has a stop bit and an end bit. You've probably seen that before in your old school loaders and whatnot. And it's asynchronous, which means there's no clock. So there's basically 2 lines, transmit and receive. So you have your transmit, receive here, transmit, receive. You want to have transmit, receive backwards. So
you mentioned asynchronous, right? So if it's a synchronous, you need a clock to synchronize.
All this is acting like
if it's asynchronous, right, you don't need a clock.
PCs.
Okay, this one we'll discuss again next
out of them, the kind we hook the headers up, and then you go to your your 9-pin adapter, but USB adapter is fine. So RS-232 is usually done with just simple commands and settings. In this case, I want to find my COM port, 25, and then this thing with a nice interblock is very common.
So again, the key points here is, I know some of you are doing the FIP, right? Right? So whenever you buy a device, you need to look at what kind of interface you need. Right? You need to use correct interface protocol libraries in order to communicate your Arduino devices.
So if I want to make this talk, I have an S, usually followed by text. I send it. Let's see, I can also increase the volume, that's command V, and then up to there's Stephen Hawking as a guest star. So, I don't know, there's not much you can really say about RS-232. It's very old, but it's still used in a lot of different places. It can be kind of slow, and of course there's no clock, so it's prone to errors and whatnot, but it works, and it's found everywhere. In closing, let's use the Raspberry Pi as an example where you can use these interfaces in your own projects. The Raspberry Pi has input-output headers here.
So anyone use the Raspberry Pi?
However, that's not a whole heck of a lot. But it does have an SPI bus, an I2C bus, and an RS-232 connection. So you can use multiple devices, as we showed today, on that single bus, greatly expanding the I/O capabilities of the Raspberry Pi. So that's just one example of how it can be used to expand your projects. Buses.
Okay.
Today's viewer question comes from the real super doofus who asks, did you take any classes in electronics? The answer is no, I'm completely self-taught, but I wish I had. However, the Element 14 community and Google search visual.
Yeah, so I think we are done today. Yeah, so next week we are going to continue a little bit on the computation and also the some of the programming. So try to you have one example, right? Your notes, right? Yeah. Try to draw your own flow chart, right? And also do some programming to practice.